Have you ever wondered why time seems to run differently when you're having fun compared to when you're not? Let's delve into the concept of time dilation, a fascinating aspect of Einstein's theory of relativity that proposes time can appear to move at different speeds depending on the observer's point of view. Think about a car trip. Have you noticed how time seems to fly when you're the driver, completely engrossed in navigating the road ahead, yet, as a passenger with nothing to do but stare out the window, the journey feels considerably longer? This is a simple analogy to illustrate how time can be perceived differently based on our activities and attention. In reality, the concept of time dilation is much more complex, involving factors such as relative motion and gravity, but the underlying idea is the same. So time is not as constant as it seems to our everyday experience. It can stretch and squeeze based on where we are and what we're doing. Just over a century ago, a man named Albert Einstein proposed a radical idea about how time and space work. Einstein's theory of relativity was nothing short of revolutionary. It challenged the established Newtonian view of the universe, where time and space were absolute and separate entities. But Einstein dared to imagine a world where this wasn't the case. A world where time and space were not separate, but interwoven into a single entity. To illustrate this, let's consider a train moving at a constant speed. Now imagine there are two events happening on this train. A light bulb turning on at the front, and a second one at the back. According to Newton, an observer standing on the platform would see both lights turn on at the same time, just as an observer on the train would. But Einstein suggested otherwise. In Einstein's world, the observer on the train would indeed see both lights turn on simultaneously. However, the observer on the platform, watching the train move past, would see the light at the front of the train turn on first, followed by the light at the back. This is because the light from the front of the train has less distance to cover to reach the observer than the light from the back. This may seem counterintuitive, but it's one of the central tenets of Einstein's theory of relativity. Observers in different frames of reference can disagree about the order of events. Einstein's theory of relativity also brought forth the concept of space-time, a four-dimensional fabric where time and space are intertwined. The presence of mass and energy warps this fabric, causing what we perceive as gravity. So, a planet like Earth isn't just moving in space, it's moving in space-time, following the curves created by the sun's mass and energy. Einstein's theory of relativity showed us that time and space are intertwined in a four-dimensional fabric called space-time, which is warped by mass and energy. This revolutionary idea not only reshaped our understanding of the universe, but also paved the way for much of modern physics. But what does this all mean for us in our daily lives? Well, let's dive into the fascinating world of the practical implications of relativity. Consider, if you will, the Global Positioning System, GPS for short. We rely on it to guide us from point A to point B, to track our runs, or even to find the nearest pizza joint. But have you ever wondered how it is so accurate? It turns out that relativity plays a crucial role here. GPS operates through a network of satellites orbiting Earth. These satellites carry precise atomic clocks that tick off time to an incredibly accurate degree. Here's where Einstein's theory comes into play. According to relativity, time moves slower for a moving clock than for a stationary one. This is known as time dilation. So, a clock on a fast-moving GPS satellite would tick slower than a clock here on Earth. If we didn't correct for this, our GPS coordinates could be off by several kilometers. Imagine ending up at a sushi restaurant when you were craving for a margarita pizza. Not quite the same, is it? And it's not just about finding your way around town. The implications of relativity stretch far beyond our daily lives. It shapes our understanding of the universe, from the smallest particles to the largest galaxies. Relativity tells us that space and time are interconnected, forming a four-dimensional structure known as space-time. It's a mind-boggling concept that has profound implications for our understanding of the cosmos. It's the reason why we believe black holes and wormholes exist, and it's the basis for the Big Bang Theory, which explains the birth of our universe. In essence, relativity is not just a theoretical concept, it's an integral part of our daily lives, from the technology we use to the way we perceive the universe. Even though the effects of relativity might not be noticeable in our daily lives, they have profound implications for our understanding of the universe and the technology that we use. So, time and space, as we perceive it, is not as straightforward as it seems. We've journeyed through Einstein's universe, where time slows down at higher speeds, a concept known as time dilation. We've delved into the theory of relativity, a groundbreaking idea that has reshaped our understanding of the cosmos. And we've explored the far-reaching implications of this theory, from GPS systems to the existence of black holes. Next time when you're on a long car ride, remember, time might just be passing a little bit differently for you than for the rest of the world. Now, isn't that something?